Hey guys, today we're starting chapter 10, circle, and 10.1 is lines and segments that intersect circles. So first we'll start with a lot of vocabularies and definitions. I'm going to draw everything inside this circle we have. If you're following along, please try to draw a really big, nice circle on your notebook so that you can also add everything onto it. So starting first, we'll have a dot right in the middle, and that will be our center. After we get the center, we'll do something that we already know before, is that from the center to any point on the circle, doesn't matter where, it's the radius. So let's say we go this way. This is radius. And then what else? What else do we know already? We have something that's called diameter, which is the whole entire segment that goes through the center. So diameter will be twice the value of the radius. So that entire line is our diameter. Alright, and then what are we doing next is that I'm gonna change to a different color and hopefully we can see the difference. Alright, so now when we find anything, any point on the circle, this point right here, and then we draw a line that is completely on the outside. This might be a little bit too light. Let me change to a different color. So again, this is the point on the circle. There is a line that goes through the point. So the only intersection of the line and the circle is at this point and nothing else. And we call this line tangent. It's not the trigonometry anymore. It's just the name of the line. It's called tangent. And if we need to call this point, it will be point of tangency. But we only have to know this line is tangent. Alright, so that's when we only have one point intersecting. Now, what if we have a line that just goes across from a circle? So you see how this line just goes within it. It doesn't matter where it goes, but it just has two intersections. In this case, we call this line the name of secant. So this line has a name called secant. And then we're only missing one more thing. So now we have another situation, is that when we find 2 points inside the circle and then connect them. So now we have a segment. So the segment has the two ends where the lines don't have any ends. In this case, this segment inside the circle is called a chord. Alright, so those are all the vocabularies we need right here. And for most of the cases, we just have to know how to identify them. So let's say for your homework, if you're given a circle with a bunch of lines inside of it, you just have to know which line is the diameter, which line is the chord, which line is the secant. And you can just go back and refer to this. Every definition has slight difference from some other ones, so make sure you know the difference. Alright, so let's continue to some other theorems. Alright, so here we have two theorems about tangent line. So tangent line is very important. We have to know how to draw tangent lines. We have to know how to use the relationship of tangent lines to solve equations. So theorems. Theorems number 1. When we have a circle and we have a tangent line on outside, So let's say this is Q, this is P. So in this case, if this is line M is tangent to circle Q if and only if line M is perpendicular to QP. So basically here, whenever you see the word tangent, it equals to a 90-degree angle. So that angle right there is always 90. Okay, the second theorem is that when you have a circle again, and then you have two tangent segments that they connect at the same point. So let's say this is S, this is R, and then this is T. Whenever you see two tangent, then what you have is that you have RS equals to TS. So the length of the top would equal to the bottom. If you look at this sideways, look at it as if it's an ice cream cone, you can see the cone side would equal each other. Alright, that's all the definitions and theorems we're covering for this section. Now let's get into 3 examples. So this video will cover the concepts we'll be doing both for Monday's homework and Tuesday's homework. So if you want to get started on tomorrow's work, you can go ahead. Alright, so example 1. Let's try to draw tangent lines. Okay, let's call it draw common tangents. So for example, for number 1, let's say we have with one circle on the top, one circle at the bottom. And then for number 2, let's say we have one circle here and then another circle here. So common tangents, that means the 2 circles are sharing the same line as tangents. Number 2 will be easier one because the common tangents, since they're connected in the middle, the only connection they will have is this one right here. So that line would be only tangent they have in common. And for number 1, for this one, it'll have a little bit more of them. So you have, here is the first one. You can see how this is the tangent, this is the tangent point. And then also it has another one on the other side. So there are 2 of them. Just think about it, there will be 2 more. So if you draw a line that goes like this, so you see how this connects here, this connects here, and then another one will be like this. So most likely the maximum common tangents you can really get is 4, sometimes 1, sometimes 2, sometimes 3, sometimes nothing. Oh, actually for this one there are more. I just realized it. So there is 1 in the middle, right? But you can also draw 1 on the outside here and 1 on the outside here. So in this case, for this one it has 4 of them, for this one it has 3. Yeah, so anything between their non-common tangents all the way up to 4 common tangents, it's all possible. Alright, so let's go to example 2. For example 2, what we do here is that we have a circle and we have a triangle. Oh, it's not good. Alright, so let's see, when we have this, and this is R because they're radius, then this is 18 and that's 24. Is this a tangent line? Tangent. So we are trying to figure out whether here is a right angle here. So in order to figure out that part, we need to use something we used to be very familiar with, which is Pythagorean theorem. So a squared plus b squared equals c squared. And a would be r, so it'll be r squared plus b squared is 24 squared equals to c squared. It's a little bit tricky here for c because c is this entire line, but we have two parts. So one of them is 18, the other one is r. So here it would be 18 plus r squared. Then we need to solve this equation. It might seem like a quadratic equation, but actually it's not. So it will be r squared plus 24 times 24 is 576 equals, for this part, you need to multiply it out. So it's 324 plus 36r plus r squared. And when you have r squared on both sides, they can simply be cancelled out. So you'll be having 576 equals 324 plus 36r. And subtract 324 on both sides. It will be 252 equals 36r. And divide by 36, r would be 7. So when you plug in 7 for both sides, you'll be figuring out that this is a tangent line and r, the value is 7. So keep in mind, whenever you see a triangle shape like this inside the circle, you are always expected to use the a squared plus b squared equal to c squared equation here. This might be a little bit tricky, but try to understand you need to use r twice, both for the value of a and for part of the value of c. Okay, I have one more and then I'll be done. This is a really long section here. Alright, so example 3, we're using the last theorem we learned. So here is a circle again, and we have two lines connecting. So for something here, let's say the top is 28, the bottom 3x plus 4. So we are trying to find x. Alright, here most likely it's not a right triangle because it has a bunch of sides and you have two tangent segments connecting to the outside. So in this case, we will always set them equal to each other. So this is way easier than the last example. It's 28 equals 3x plus 4. Subtract 4 on both sides. 24 is 3x. So divide by 3, x is 8. And that's it. Alright, that's everything we're learning about 10.1. We'll start doing circle for the next month. So please try to understand this. I'll see you next time. Bye.